Alright, so today our topic is reflections. And these are your notes for 9-1, so we're going backwards in chapters. And there are 4 different transformations, as I said before: rotations, reflections, translations, dilations. I think I got them all. So we're going to focus on reflections today. And then we're going to also look at symmetry, which is not a transformation, but it's part of the process. So an operation that maps an original figure, so you're going to be given an original figure and do something to that figure to create a new figure. So an operation that maps an original figure is called the preimage. So you'll hear me talking a lot about preimage. That's your original figure onto a new figure called the image. So a transformation can change the size. Let me change my color here. Can change the size, position, or shape of a figure. So it just transforms it in some way. And this isn't a proper word, so just to let you know. I'm going to use the word just for your benefit. A flip is a reflection. So a flip over a line called the line of reflection So when we reflect something over that line of reflection, the image and the pre-image are going to be equal distances from that line of reflection. So on the next little bullet point here, each point and its image are, I'll use blue again, the same distance from the line of reflection. And then there's all kinds of possible lines of reflection that you could have. We're going to look at all of them today. So you could have the x-axis or the y-axis. You could have a vertical or horizontal line in the form of y equals a number or x equals a number. By the way, y is your horizontal, and x equals a number is your vertical. And then we could also have diagonal lines in the form of, and these are the harder ones for you, y equals x or y equals negative x. But I'm going to give you an easy way to figure those ones out. Alright, so let's just practice, and I'm going to do one, you're going to do one. So go ahead and plot the first triangle ABC. They gave you the vertices, so plot the points and draw or connect the dots. Connect the dots with straight edges. So I'm always going to do my pre-images in blue and my reflection in red. I'll go with it. And I can't exactly plot super terrifically on this, so I'm going to try my best. And please do name your ordered pairs as A, B, C, or whatever they've given you. Preimages always have capital letters for their vertex points. You're going to find that the image, which is the result of our reflection, is going to have this apostrophe, if you will. It's called a prime, so it's the A prime, B prime, C prime. That denotes our image, our final result. And so we need to draw in our line of reflection. So right here, they've given you your line of reflection. It's the x-axis. So if I were you, I would highlight that x-axis because that's the line that we're reflecting across. All you have to do, it's pretty simple. You're going to take each point. So start with point A. How far is point A from the line of reflection? How far? 2. So you're just going to plot a point 2 in the opposite direction. So since it's above, we're going to plot 2 below. We're going to call that A prime. Name that ordered pair. What's that ordered pair? -4, -2. And then look at point B. How far is point B from the line of reflection? 7. Right? So we're going to go 7 in the opposite direction and plot a point. And call that B prime. Name that ordered pair. 4, -7. And then finally, how far is C from the line of reflection? Just 1. So we're going to go 1 on the other side and call that C prime. And name that ordered pair. 5, -1. And then we're going to connect those points. And as you can see with the reflection, does the size change? Does the shape itself change? Nope. All it did was flip over that line of reflection. What else do you notice about the ordered pairs of the image versus the pre-image? What do you notice about the x values? The x values are the same. What did you notice about the y values? The signs changed, right? So when we reflect over the x-axis, the x values change or stay the same, but the y values change their signs. So you go ahead and do number 4. So you're doing number 4 here on your own. So plot, you've got to plot. If I don't see you plotting both the image and the pre-image, you're not doing everything you're supposed to. So you got to plot both of them. And I teach reflections not by using your math, but just by mapping it and counting. So what shape is this? Oh, I guess I told you. It's a rectangle. Make sure you highlight your line of reflection. Oh, this one's a rhombus. So I'm totally doing the wrong one. So I'm going to erase what I've done. So share your results with those around you. Talk, show, discuss. Are you not done? I did it wrong and had to redo it and be done. So here's what your number 4 should look like. How good are we with this? Thumbs up or thumbs down? Have we done this before? Yes? Okay. So y is going to be the same thing, only we're going to reflect the other direction. So as you look at number 2, go ahead and plot the rectangle. Go ahead and plot the original. So P is 1, 2, and Q is 2, 5. R is 8, 3, and S is 7, 0. And then this time your line of reflection is the y-axis. So we're going to highlight that y-axis. And then we're going to go even distances away from the y-axis. So this time we're flipping to the left. And so as we look at our image, or where our image is going to go, P is how far away? 1, so you're just going to go 1 to the left. So plot P prime. What ordered pair is P prime? -1, +2. And then how far is Q away? 2. So plot Q prime. And then S is 7 away, so we're going to go 7 to the left. And call that S prime. And then R is how far? 8, so we're going to go 8 to the left. And call that R prime. And connect. So again, you don't see the shape changing. Bless you. And we're going to name all those ordered pairs. So Q is -2, 5. And R prime is -8, +3. And then S prime is -7, 0. So this time when we reflect over the y-axis, what do you notice is happening to the x values? The x values stay the same? The x value signs changed, the y values stay the same. So when we reflect over the y-axis, y stays the same, x changes signs. When you reflect over the x-axis, x stays the same, y changes the signs. Okay? That's just a good check. All right, so we're going to skip 3. So flip to the other page. This time we're going to look at reflecting over things other than the x or the y-axis. So in number 5, we're going to reflect over the line x equals 4. How do we plot vertical and horizontal lines? How am I going to plot this line? These are the easiest lines in the world to plot. You see how it says x equals 4?
Yeah.
Place a point on the x-axis at 4. Isn't that where x is 4? How are you going to cut the x-axis into 2 pieces? Are you going to cut it vertically or horizontally? It has to be vertically. So x equals is a vertical line through the x-axis at 4. That is our line of reflection. It's highly important that you draw that in there because it's so much easier to see and count when you do that. So now let's draw our preimage. So J is 1, -1. And then K is 2, 3. And then L is 3, -2. And connect those with a straight edge. And there's our triangle. we are going to reflect this over here. So now it's no different. If you can plot that vertical or horizontal line, it's no different. So how far is L from the line of reflection? How far? 1. So we're going to plot our image 1 to the right and call that L prime. What's that ordered pair? Now it's really important that you're naming them because things are going to look different now. So what's that ordered pair? 5, -2. How far is J? How far? 3, so we're going to go 3 to the right. So plot J 3 to the right. That's J prime. What is this ordered pair right there? 7, -1. And then finally K, how far is K? 2, so we're going to go 2 to the right, and that's K prime. What is that ordered pair? 6, what? 3. So shape didn't change, it just flipped. So look at question 8. Question 8, our line of reflection is y equals -5. Where are you going to plot a point? On what? So plot a point at -5 on the y-axis. How are you going to cut that y-axis into 2 pieces? Horizontal lines. So we're going to go this direction. So there's our line of reflection. Plot your preimage. So there's M. N. So there's our image. You go ahead and reflect it up equal distances. And then name the ordered pairs. And I'll try to do it quietly. And then check how you did. Thumbs up, thumbs down. How comfortable are we with that? Good? Okay. So the only thing I want you to do on questions 7, 9, and 10, no, I take that back. Let's go back here. The only thing I want you to do on questions 6 and 7 is put in the line of reflection. I want to see that you can draw in the lines of reflection. So I'm going to cover this up, and you're going to put in those lines of reflection for 6 and 7. Share your answers with those around you. See if they agree with what you did. Talk and show, talk and show. All right, so here's your lines. Vertical line through -1 for number 6, and a horizontal line through +2 for number 7. Are you good with that? Because if you can plot those lines, you should be fine. All right, the last 2 are the hardest ones, or the last 4, I guess. We're going to have to plot a line y equals x. Does anybody know what that line looks like? It is slanted. Yep. Was that what you were going to say, Dustin? Isn't this kind of in slope? Well, it is. Isn't this in slope-intercept form? So it's y equals mx plus b. What's plus b? Where's the y-intercept? It's not shown, so where is it? 0, right? So isn't the y-intercept right here at the origin? What's the coefficient of x? What's the coefficient of x? 1. Isn't that the slope? Isn't the slope 1 over 1? Or -1 over -1? And all this is saying is that the x and the y values of every ordered pair are identical. So your ordered pairs are 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, that, and so forth. So we're going to go ahead and plot that, and you have to get good at it. So here's 0, 0, 1, 1, 2, 2, etc. I'm going to go a little further out here. Whoops, that would not be it. I'll keep with my pattern I was doing. And then go negatively. Alright, so it's going to be hard for me, but I'm going to draw in my line of reflection. I missed it a smidgy bit, but you get the idea. It's going to be really hard when we draw our image to actually count distances away because it's a diagonal distance, and we can't count diagonally in the coordinate plane. So I'm going to give you an easy way to figure it out, but let's go ahead and draw our preimage first. So we've got -5, -2. So here's x. We have -3, 4. And here's y. And then -1, 1 is z. So this is a triangle. So as you can see, it's going to be hard to count the distance diagonally that z is from that line of reflection. So instead, this being our line of reflection, all that happens is your x and y values switch. That's it. So I'm going to actually find my ordered pairs to the preimage, to the image, and then plot those. And watch what happens. So in x, if you switch these ordered pairs around, don't you get -2, 5, -5? We get -2, -5. Let's plot that and see where it's at. -2. This would be x prime. Do these appear to be the same distance from the line of reflection? Yes or no? That worked then, right? All right, so what's the switch of y prime? Just switch it. What do you get? 4, -3. So plot to the right 4. -3. And then that's y prime. And as you can see, here's y. Y is quite a bit farther away than the other points, and those appear to be equal distances. And then the last one is z. Z is going to be 1, -1. And so 1, -1 is here, z prime. And again, you can see that z are equal distances away. How'd we do? That worked. So look at number 12. Number 12's line of reflection is y equals negative x. What do you think that means? If y is 1, what's x? Negative 1. If y is negative 4, what's x? Positive 4. So your x's and your y's are opposite signs to each other. So what that does is it changes the line from going in this direction, it goes in the opposite direction. So you still go through 0, 0, but instead you're going to plot negative 1, positive 1, negative 2, positive 2, and so forth. Oh, I was a little squiggly, but you get the idea. So let's plot your preimage. Which is S. And then 0, negative 3 means you don't go right or left, but you go down 3. And there's your T. And then this is our U. So then we're going to find our image points first. So here's what happens when we have y equals negative x. The x and y still switch. So x and y still switch. But they both change signs. Because of the negative x, so instead we're going to switch for s, we're going to switch it, the negative 1, negative 6 switch, but they both change signs, so it becomes a positive 6, positive 1. Let's see if that works. So plot to the right 6. One and call that S prime. And then look at the 2 points. Are they directly across from each other? Yep. And they appear to be equal distances from that line of reflection. So what's your point for T prime going to be? If T is 0, negative 3, what's your T prime point? Not 0, 3, you got to switch them. 3, 0. So switch them and change signs. 0 doesn't have a sign, so 0 stays 0. And so plot the point 3, 0. 3 implies that you're going to go to the right 3, and 0, you're not going to go up. So you're right here. And this is T prime. And then what's U going to be? Bless you. What's U going to be? Switch and flip. What is it? 4, negative 3. So to the right 4, and so that is U prime. And then connect. My line of reflection is off a smidge. Sorry about that. But you can see the dots. You can see where my dots were. So here's that line of reflection where the dots are supposed to be. And these are equally across from each other. Okay, so I'm going to leave 10 and 11 for you to try on your own, and then you can check your answers online. But, you know, all you're doing is when y equals x, you're just switching positions. X becomes y, y becomes x. When you have y equals negative x, you not only switch positions, but you also change those signs. So you're going to have to learn that part of it because you can't just map it visually for those two. Are there any questions on that? Okay.